Hello friends, in this video lecture I will discuss about complex numbers and their several forms in Cartesian coordinate system and in polar coordinate system. Also, we learn in this lecture about the geometric concept of a complex number. Consider there is a Cartesian coordinate system and we draw two perpendicular lines where they meets at the point O. This point is known as origin, and the x-axis and the y-axis are the two perpendicular axes, and we are acquainted already with this coordinate system as we have done it in our real system. In our real number system, what we have done, we consider a plane and two perpendicular axes x and y, but in complex plane, or it is known as argon plane, we call the y-axis as the imaginary axis. It is the imaginary axis, and the x-axis is known as the real axis. And is this system where this system lies, the plane is called the argon plane or complex plane. And in this complex plane, if a point P is there, then the z, the complex number z, is called the affix of the point P. Now, this is the system. Here, see that the line joining the point P and the origin is the distance of the point P from the origin O. This distance is the modulus of z. If a complex number z is x plus iy, then the modulus of z will be this x plus root over x square plus y square. This root over x square plus y square. Here, see that if there are 2 points P and Q with their affixes Z1 and Z2 respectively, then we can see these phenomena like our vector system. In vector coordinate system, what we have done, we call these as vectors and found the vector of PQ. In complex number, the distance of the point Q from the point P will be the modulus of Z2 minus Z1. And obviously, like our vector coordinate system, PQ is equals to OQ minus OP. Consider there are 3 points in an argon plane. In an argon plane, there are 3 points A, B and C with the affixes Z1, Z2 and Z3 respectively. Then, if we draw the lines, then a triangle forms, and in this triangle, the distances, that is the sides of the triangle, will be AB is equals to mod Z1 minus Z2, AC which is mod Z1 minus Z3, and BC, which is mod Z3 minus Z2. This one, and this one. For equilateral triangle, these sides will be equal, and thus we have mods of Z3 minus Z2 is equals to mod of Z1 minus Z2 is equals to mod of Z1 minus Z3. This relation will we have. Now we consider the another form of a complex number, which is polar form. What we have discussed till now is the Cartesian form of a complex number, but we are going to define, or we are going to acquainted with the another form of complex number, which is the polar form. In the polar form, what we do is we want to locate a point by the two parameters. One is the distance of the point from the origin, which is denoted by r. Therefore, r will be the modulus z, and another is the angle that makes the line joining the point P with the origin, which makes the angle with the positive x-axis. This angle is known as the argument of the complex number z. So, the polar form, in this polar form, what we have got, that r is equals to root over x square plus y square, and theta is equals to tan inverse y by x, that is tan theta is equals to y by x. From this figure, we see that MP, here MP is the distance whose value is y, and OM whose value is x, and that's why tan theta is equals to y by x. This will be the value. Then our x is equals to r cos theta, y is equals to r sin theta, and thus the z, the complex number z will be r into e to the power I theta. Thus we have the two forms, one is Cartesian form, another is polar form. In the Cartesian form, we can convert a complex number from any of these two forms. We can travel also any of these two forms. Among these two forms, Cartesian forms and polar forms. In the Cartesian form, if suppose a complex number is given in Cartesian form and we want to find its polar form, then what we do? We find, therefore we have given the values of x and y. We have to find the values of r and theta, and then what we do? We find r is equals to root over x square plus y square, and theta is equals to tan inverse y by x. Mind that this theta will be the principal argument of the complex number x plus iy, and this principal, what will be the principal argument value, we have discussed in our previous lecture video. You can find in my YouTube channel Math Buddy. You can see this video too. Okay, now if a complex number is given in the polar form, that is, we are given the values of r and theta. What we want to know? We want to know the value of x and y. Then it is easily can be obtained by putting x is equals to r cos theta and y is equals to r sin theta, and then we got the complex number x plus iy. These are the two forms of a complex number. Now, if there are 4 points A, B and C, D with the aphysis Z1, Z2, Z3, Z4, if these two lines makes an angle theta, then this theta is equals to argument of Z4 minus Z3 by Z2 minus Z1. This will be the argument. Thank you.